Hi, welcome. This video is for Algebra 1, your Apex Unit 11, Section 2. This will be the first video in which I'm going to start working a couple problems when you're told to convert from standard form to vertex form for quadratics. The way we're going to do that is by learning a new tool, new section, new tool. It's called completing the square. When you're told to find vertex form, that's the same thing as being told complete the square. So depending on what instructions you're given, this is what they're talking about. This new tool we're going to use, that is really, it just gives you more flexibility when you're approaching these different quadratic situations. So here we go. In your work, you are told, let's start this off right, 11.2.1 or point 2. You are told to rewrite in vertex form. Okay, so initially, we just need to know what vertex form is. What you've been working with so far is something that looks like this. This is called standard form. Standard form. But what we want is something that looks like this. Vertex form. And even though our parabola is going to have the same exact inputs and outputs, we just want it to appear in this new different way, the vertex form. And the reason why this form is useful is because if you have an equation like x plus 3 squared, and you say minus 36 equals y. If you have an equation like that, and you're asked to find the maximum, so your parabola is like this, or the minimum, you can easily just look at this formula and say, aha, here's my h, here's my k, so my vertex is at the point negative h, comma k, which in this case is negative 3, negative 36. So without really doing any math, when you have a quadratic in this form, this vertex form, all you have to do is look at it and say where the maximum or minimum is. It tells you where the vertex is. So that's kind of the whole point of being able to go from standard form, what we already know, into this new vertex form. The method we use to get there is completing the square. Okay. For this video, I'm just going to work through one of your problems. It really takes quite a few times to just try it on your own before you can become comfortable with this completing the square method. So in your Hapara, I'll also post some links to other YouTube videos that I really like for this. All right, let's do a problem. Let's do a problem of completing the square. to rewrite in vertex form. I'm given this. Y equals x squared plus 12x minus 5. And I'm told to rewrite this in vertex form. So we're going to take this and we're going to make it so that we have a perfect square piece. Some number. Oops, getting off the page. A perfect square piece with some number, some constant. So here we go. In order to make a perfect square, first I'm going to just care about this x part. This is the piece that I want to put into my parentheses. So y equals x squared plus 12x minus 5. In order to make this a perfect square, I need a perfect squared trinomial. I need a perfect squared trinomial. I need something to be right here to make that factorable in a perfect way. And the way I'm going to do that is I'm going to cheat. I'm going to lie and say that I have something here that can make this factorable. And the easiest thing to put there is using this trick. I'm going to take my b value, or the number that's attached to x, so b. I'm going to divide that by 2 and square it. So in this case, 12 divided by 2 is 6, squared is 36. Okay, what I did here just changed the math problem I'm working on. This is a different problem than what I started with. And in math, if you want to change something, you need to correct for it. So I added 36. The way I can correct for that is by subtracting 36. In your Apex work, they kind of go both ways. They'll say, since I added 36 here, I need to subtract 36. Or they might say, you added 36 to this side, so you need to do it on the other side. They're both the same. They work the same way. Just because I have that side all nice and neat and clean, and keep all my mess over here. So I took half of my b value, 12 divided by 12 divided by 2 is 6. Took that value and I squared it, 36. Since I'm just adding in a magical 36, I need to correct for that. I need to also subtract 36. So now my problem looks like this. Y equals x squared plus 12x plus 36. I'm just putting in parentheses because this is the part I'm working with. It doesn't change the problem. Minus 41. This just went to that. All right, one more step until this is in vertex form. I have this nice, pretty, perfect square trinomial. So now I can write this in a nice factored form. There it is. This is why we want to use half of b squared, because then it just turns in to this nice perfect binomial. Because, and this is just me working on the side, this isn't extra steps of the problem, I'm just explaining here that x plus 6 squared is the same thing as x plus 6 times itself And we can distribute here to show x times x, 6 times x, another 6 times x, and 36. So what I'm showing is that x plus x squared is the same information as this piece. And I made up for adding this 36 by also subtracting 46. And that's it. This is vertex form. I have something squared minus a number or plus a number. I do want to add that your vertex is at negative h comma k, and this is your h value, this is your k value. So the vertex of our original problem is at negative 6 comma negative 41. Okay. And I do want to show you in picture form that I'm not just making things up here. So let's go, here we are, let's go to Desmos. Let me check that. Nope, it's not pulling up. Window capture, let's see here. All right, let's go take a look at this graph. I want to see where the vertex is of x squared plus 12x minus 5, the original problem. Here we are. Here's a picture of our parabola that's made from this function. And I'm going to go look at this vertex. It looks good. If I click on it, there it is. Negative 6, negative 41 for our vertex. We can also look at where our solutions are, our x values, and they do not fall on very nice numbers here. In fact, these might be quite complicated. So let's take a look at that as well. This is another useful reason to use completing the square or vertex form, is we can solve it by just using square roots. We don't have to do any more factoring or any sort of guess and check and getting lucky. We can just use square roots for really complicated numbers. So remember, y equals x plus 6 squared minus 41. If we're told to solve for our x-intercepts, that means we're going to use y equals 0. We're just going to set it equal to 0. So 0 equals x plus 6 squared minus 41. The goal is to get x by itself. We're solving for x. Scoot this up a bit. So I'm going to add 41 to both sides. And I get 41 equals x plus 6 squared. Still trying to get x by itself. So I'm going to go in here and take the square root of both sides to get rid of that square, which leaves me with the square root of 41 equals x plus 6. Almost there. Remember, Whenever you introduce a square piece, you need to include both signs. We have a positive and a negative version. One more step to get x by itself. We're going to subtract 6 from both sides, which gives us negative 6 plus or minus the square root of 41. There it is. That is a mean, complicated solution that we would not be able to factor or just guess by looking at the graph. It doesn't fall nicely on anything, but we're still able to solve it in relative ease. All we're doing here is what we've already learned. We're just getting x by itself. Okay, I'm going to work a couple more examples in the next videos. Hold tight.